how it can be made. We have seen that we have found that in where 1 is present, and according to that, we have seen the inputs that x1, x2, x3. We have seen the inputs, and from there we make these equations. Now, to determine the logic, of each encoder input, it is necessary to find the control functions. It is necessary to find the control functions at the corresponding register onto the bus. Now, based upon that, we have seen that which register has the particular access at that particular moment, which register has the access on the bus. We have seen that. So now, to determine the logic of this each encoder input, it is necessary to find the control functions of this corresponding register. That means that register's control functions, it is necessary to find out onto the bus. For example, to find the logic that makes x equal to 1. So x1 equal to 1, that means when x1 is 1, you see, when x1 is 1, in that time, address register, that time address register is selected for the bus. So we will see, we here we can for address register, all the address So based upon that, we will see that all the statements that extract the statements that the address register as a source. Because x1 is what? X1 is consist for the if x1 equal to 1, that means address register will be get the permission to use the bus. So all the transfer statement, all the register transfer statement will be over the address register as a source. It consists at the address register as a source, because we are as an example we have address register, sorry, into the program counter, into the program counter, and at timing signal T5 and at output signal D5, we also same thing we are doing, that the content of the register we are transferring into the program counter, because we have said that when register transfer statement, the register transfer statement will go here and it will extract the statement in this particular operations. So this is at the timing signal and output signal. We are performing this operation. So now if we make the Boolean functions of x1, now if we make the Boolean functions of x1, it will be d4 t4 plus d5 t5. That means the output signal and the timing signal plus the output signal and the timing signal. So both of this addition will be presented as the x1 Boolean function. So x1 equal to d4 t4 plus d5 t5. So this is will be the Boolean function for the x1. So this is about all the output. We have seen that the output of the control logic circuit, these are the all five. These are the all five things, all five signals to control. First, we have seen some signals to control the input of the 9 register. Then in the second type, we have seen that the signals to control the read write of the memory. This is the signals to control our S2, S1 and S0 to select the register output, which register will give the permission for the bus at that particular moment. And we have also seen the signals to set, clear or complement the flip-flop. And the fifth one, the signals to control the adder and logic circuit. So these are all the output signals. These are the output signals of the control logic circuit. And these are the examples. Two examples I have shown you. So this is all about for designing a basic computer. Okay. Now today we will start how the addition subtraction, the addition and subtraction, how it can be done in the computer we will see, and a thing that is very important, that is the Booth's multiplication we will see today. So first, before starting that addition and subtractions algorithm, basically in this way, in our arithmetic logic unit, the operations of addition and subtractions are done in using this algorithm. This addition and subtraction is done. This is very much simple. Everyone from the start of the beginning, you have understand this, because we know that how the addition can be performed. So that means addition, if we perform the addition, we have how many conditions present? We know that if we make addition of two variables, how many conditions there is present? This may be that this we are taking like say a and b, these variables we are taking a and b, let's say. So that means if we perform the addition, there may be 4 conditions present, that both a and both b may be positive number. Then both a may be positive number, b may be negative number. That means our variable can be what? The both of them can be positive, or one of them positive, another one is negative, or this may be the condition that one is negative and this will be the positive, and this is what? This is another, that both the numbers are negative, and we can perform the addition operation. These are the 4 conditions, that there may be variables that may be both positive or both negative, or one positive, one negative, and one negative and another positive. These are the 4 conditions. So first, this table, you see, we have written the condition for plus, and same as that for minus also we have written like this. For minus conditions also the same way we can perform that. We can say both positive and between them the minus, one positive and one negative, and we perform the subtractions, one negative and another positive. We perform subtractions and both of them are negative, and we perform subtractions. So we have seen total how many conditions are present? 8 conditions are present. Now from there we will prepare our table. You see, we have written thing, that is add magnitude. And for subtractions magnitude, that means from here we will perform the addition and subtractions both from this condition. So we have written here add magnitude, and here also see subtractions magnitude. Now for addition you see only one column is present. Why one column is present? Because for addition we will only perform the addition, but no other thing, there is no other condition we have to see. But for subtraction magnitude, you see, there may be condition for subtractions that A greater than B, or maybe that A less than B, or A is equal to B. These three conditions are present. But for addition, there is no such condition. We only add the two numbers. So that's why add magnitude, you see, only one column is there. But for subtractions magnitude, we have three conditions. When the first is greater than the second variable, or when the first variable is less than the second variable, and when both the variable are equal. So like this, we prepare the table. Now, for add magnitude, how will which we will use as the add magnitude? Now you see, if we perform this for add magnitude, in this middle, always plus will be present. Always plus will be present in the middle of this. In the middle of the variable, always plus is present. Then only this we will consider as the add magnitude. Because you see, if we do this plus A plus B, so that means it will be plus, and if we take common, that it will be A plus B. So okay, but those condition which have in between minus, we cannot take that. We cannot take this, because here only add magnitude. This column is for the only add magnitude. So that means we only use the plus in between them. We only use plus. So we only choose that which have in the middle plus. Okay. So this, if we consider this, then plus A plus B, and if we take the plus common, then also it will be plus A plus B. Okay, no problem. But if we consider this plus A minus B, so that means if we take this common, it will be A minus B. Like this, it will be A minus B. So that means we cannot take it. We cannot take this, because here in the middle it is minus present. So we cannot take this in the our add magnitude. We cannot add this in our add magnitude. So this condition we cannot take in the add magnitude. For this also, if we take, this will be A minus B. Like this, it will look like this. If we take minus in minus A plus B, so if we take the minus common, then also it will be A minus B. So in middle it is minus. So okay, we cannot take this also. But if here we take, then if we take the minus common, it will be A plus B. So that means this will be, this we can take. Here also in between it is A minus B, so we cannot take it. Here also, if we take, in this condition, if we check, then if we this take the plus, so A plus B, it will make A plus B, because minus minus it will be plus. So A plus B. Okay, so that means we can take this, but we cannot take this because in middle it will be minus. Same as for that, if we take this minus common, because it will be minus A minus B. So if we take minus common, then it will be make as A plus B. So that means we can take this also. We can take this also, because minus A and it is minus plus minus minus B. So if we take the minus common, then that means minus A plus B. We can take this. But here minus A plus B. So that means if we take the minus common, then it will be A minus B. So that means this condition we also cannot take. So for this add magnitude, if you see this add magnitude, the conditions will be this. We can add this only, this, because in middle always plus is present. So we can take only this. Now when we have to getting the subtraction magnitude column, when we have to go the subtraction magnitude column, in that you see, and now what we have to check, a greater than b, and those conditions, that means here this, and this, we will not check it because it is already present in the add magnitude. That means we will check now only this, and this two. We only check that because other operations are already present in the add magnitude. So now over them we will check in the subtraction magnitude. So that means, and now subtraction magnitude, it will be plus a minus b. So this, because a is greater than b, here a minus b, that means a is greater than b. So we will take that. Now if we loop this, then if we take the minus common, it will be minus a minus b. So this will take, because in the middle minus should be present. In the middle minus should be present. So we can take this. Here also plus a minus b. Okay, so plus we take common, it will be a minus b. So that means this is also present. And if we take this minus and it will minus common, then it will make us a minus common a minus b. So that means these are the conditions fulfilled. Now when a is less than b, now to fill up this column, a less than b, what we have to do? Nothing we have to change, only here change the position. Here you write b and here you write a. So you see all the b minus a we have written. And what we have done, we have only changed the this this operations. That is, here plus, here it will be minus, here minus, it will be plus. Where there is plus, it will be minus, and here it is minus, it is plus. So that means like this, we can fill up this column. And for a equal to b, what we will do? For a equal to b, that means both are equal. So we will write a minus Okay, so that means we will give here now a minus b, a minus b, a minus b. We will write, and in front only give the add operation. So like this, we will prepare this table. Okay, समझ में आया सबको कि कैसे इस टेबल को बनाना है?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So like this table should be prepared, and the addition and subtractions algorithm, this are performed like this in the computer. The addition and subtractions are performed through this add magnitude and subtractions magnitude. It is performed in our computer. Now we will see the multiplication, how the multiplication has to be done. The multiplication we done in the our system. Now for sign multiplication, for sign values, that is minus plus, it is given for sign multiplication. This algorithm is very much important, that is the Booth's algorithm. So how this Booth's algorithm work, we will see. Now let's say we have two variables, like two numbers we have taken, and we are this multiplication we are doing for the sign values. So that means let's say we have -7 and into +3 into +3. These are the how we have taken as an example. So if we perform the multiplication, what will be the value? The multiplication value will be -21. Now this is the simple multiplication we done, but how the computer should done? The computer will do using following this Booth's algorithm. Using this Booth's algorithm, the computer will perform. So how Booth's algorithm works, we will through flowchart we will see, and then we will discuss this example that how we perform. So first we will see the flowchart. Now this is what -7. -7 is the multiplicand. -7 is what? That means which number you are multiplying. That will be what? That is the multiplicand. And through which your multiplication is done, that number is what? That number is multiplier. That means through which you are multiplied, through which number you are multiplied, that is the multiplier. And this is what? This is the product. After multiplication of multiplier and multiplicand, we get the product. That is the thing. So flowchart will looks like that. In this flowchart, if you see, this flowchart consists of the first start. That means start is the main thing. From here we will start. Then you flowchart all the variables that is required. That is required. We will initialize it here. We will initialize first. So M stands for the multiplicand. Now what this is? For this multiplicand is what? This is the n bit register. This is the this M. M is for the multiplicand. And this M is what? This is the n bit register which hold the multiplicand. This M is what? This M is the n bit register which hold the multiplicand. Now what is this Q? Q is also our, we say that multiplier. This is also what? This is also a n bit register. This Q is also a n bit register which holds the multiplier, which holds the multiplier. And Q0 is what? Q0 is initialized with 0. That means it is set with 0. Why? Because single bit. Q0 is the single bit. And this single bit is what? This single bit which is initialized with 0. Then A. A is also initialized with 0 because after start we all initialize the variables first. So A is also what? A is initialized with 0. That means A is what? A is the accumulator. N bit, accumulator is the n bit which is initialized with 0. And n is what? N is the number of bits. Number of bits required to present the multiplicand. Number of bits that is required to represent the multiplicand. This is the n. This is also n. Now first, after initialization, what we done after initialization? After initialization, if Q1 and Q0, we check that if Q1 and Q0, if it is 1, 0, then we will perform A equal to A minus N. That means the value that is stored into the accumulator. With this, the subtractions will be done. The multiplicand, what is the multiplicand? With this, the subtractions will be done if it is 1, 0. But if it is 0, 1, we get the value of Q1, Q0 as the 0, 1. Then we will do what? The value that is stored into the accumulator. With that, the addition of the multiplicand which we have. If it is 0 1. And if it is 0 0 or 1 1, both the same, in that case we will perform the arithmetic shift operation. Arithmetic shift means we have two shifting, that is right shift and left shift. So we will perform the shifting operation, the right shift operation here. You say shift right, that means right shift operation we will do. And after this, the n value is what? N value will be decreased. And after n value is decreased, we check that if is our n is equal to 0. If our n is not equal to 0, then we will perform these operations again. And if our n value is 0, then the result in AQ, the result in the AQ we will do, and it will we will take that and we will stop our operation. So this is the flow chart. This is the flow chart of how the multiplication is done. Now we will take our example and see that how it can be done using this flow chart. So what we have value? Minus 7 into plus 3. This is our value. So minus 7 plus 3. Minus 7 is what? This is the multiplicand. And this is what? Q. This is the multiplier. This is our multiplier. So first what we'll do, our m value is what? Minus 7. So you see m is equal to minus 7. So minus 7 means what? If any value. Now for representing 7, if you think that representing 7, how many bits are required for representing 7? Now for representing 7, we have required only 3 bits. Because 7 is what? If we convert it into the binary, then it will be 1, 1, 1. Only 3 bits are required. But then why I have written 4 bits here? This is because for minus, for representation of the minus, we require an extra bit. Extra sign bit is required. So that's why we have to require an extra sign bit. Now here I have given 0. Why? Because minus 7 2's complement. If there is minus value given, that means we have to perform 2's complement of that number positive, of that number's positive value. So 7's positive value, if we take and using the 4-bit representation, what it will be? So plus 7 4-bit representation. This is what used for the sign bit. So one extra bit we have taken for the sign bit. So plus 7, representation of plus 7 is using 4-bit, it will be 0 1 1 1. So that means we have seen that minus 7. So minus 7, if a value that is given as the minus, then if a value that is given as the minus, we have to represent that bit. We represent that number. How many bits are required? For representing 7, we require 3 bits. But we have taken 4 bits because it is the minus value. That means for minus representation, we have to take another value, for another bit we have to require. So that's why we use the 4-bit representation. Now this 4-bit representation, what of the 4-bit representation we will do? This 4-bit representation we will do for the positive number of that number positive value. So that means using 4-bit we will see the positive of 7 because it is minus 7. So that means positive number of this will be plus 7. So plus 7 is what? If we convert it plus 7 using 4 bits, then it will be 0 1 1 1. That's the thing. But the number is negative. So that's why what we have to do, we have to perform the 2's complement of that number. So the 2's complement of number, that means 0, 1, 1, 1, 2's complement of that number. So if we perform 2's complement means we have to convert it 1's complement, and after 1's complement, we will do the addition of 1. So 0, 1, 1, it will be converted into 2. If we convert it into the 2's complement, then first, if you do the first complement, it will be, in the case of 0, it will be 1, and in other cases, it will be, for 1, it will be 0. That is the first complement. That vice versa, if there is 0, then it will be 1, and if it is 1, then it will be 0. So this is what, this is the 1's complement. And for 2's complement, we have to add 1 here. So we have added 1. So the value that is 1001. This is the -7 representation. This is the, if we -7, binary value will be 1001. This is the -7, our value of my binary value. And if we have -m, -m means what? -m means we have to take 2's complement of this number again. If the value is -m, if, because it is the value of m, but if the value is -m, then minus means what? We know that we have to make 2's complement. We have to make 2's complement. So 2's complement means this number 2's complement we have to done. So that means 2's complement of this number, first 1 complement 0, 1, 1, 0, and with that 1 should be added. So it is 0, 1, 1, 1. So if it is -m, then the value will be 0, 1, 1, 1. That means, why? If you see, then it will be clear. So -m, that means -7. This is the thing, because m value is what? M value is -7. M value is -7. So we write it and it has a minus value. So minus minus, it will be +7. So +7, if we convert it into using 4 bits, it will be 0, 1, 1, 1. So extra bit for the signed representation. Extra bit we required for the signed representation. ठीक है? Clear? समझ में आया कि 2's complement नेगेटिव नंबर जो है उसको 2's complement कैसे करते हैं, और 1's complement एंड नेगेटिव नंबर का समझ में आया?
Yes, sir.
Okay. So this is what our, first we take this -7. So first what we do, we have done, we have m value we have taken, and we get this m value here, and for -m also we have get that value. Okay, now we will trace this table. We will prepare this table first. Now first we have seen there will be n. N will be there because we have seen that n is equal to n-1. That means n is required. So here n, there will be n. This is the tracing table. This is what? This is the tracing table. Now there will be a accumulator. Then it will be q, and here it will be q0, and another attribute will be action or comment. This is the thing. So first, using this flowchart, we will see that what first we have done. First, we have done that initialization. In this flowchart, first thing we do, that is the initialization. So initialization means first we will put the values here. So for representation of -7, we have seen that using 4 bits we represent -7. So that means n is what? N is the number of bits required for the multiplicand. This is the multiplicand. So there is 4 bits required for representing this multiplication. So that's why we have written 4 here. Now for accumulator, for initialization time, accumulator has what? All the accumulator value is 0. So 0000 because 4 bits. So we represented it as a 0000. And for Q, Q is what? Q is for the multiplier. Q is multiplier. So what multiplier we have? Our multiplier is plus 3. So we have to convert it in the 4 bits because n is 4. So that means if we convert plus 3 into 4 bits, then it will be 0011. That is why it is written 0011. And Q0 is what? This is a single bit. Now single bit which is initialized as 0. Single bit which is initialized as 0. So this is what initialized as 0. Now what this Q is? If it is Q0, then this Q will consist, here it is 4 bits. That means Q will consist from Q1, Q2, Q3, Q4. If it is 5 bits, then Q will be Q1, Q2, Q3, Q4, Q5. Like this. But here we have 4 bits. So that means this Q will be Q1, Q2, Q3, and Q4. This 4 bits. So it is 0011. And what actions we are performing at the first time? We are performing initialization. Okay. So after initialization, what we have to check? If we see the our float chart diagram, that what will be the Q1 Q0 value? What will be the Q1 Q0 value? Now here Q1 Q0 value is 1. This is the Q1. So 1 and 0. 1 and 0 means what? If it is 1 0, then we have to perform arithmetic a equal to a minus m. This operation we have to perform. If we check the flow chart, now if it is q1 1 and q0 is also 0, then only what? Then we will do this operation. So we can also write it like this: a plus minus m. We can write this like also. Okay, so in the, I will detail explain it in the next class. So, time already less, so I will not able to continue this total today. So in next class I will again explain from here. Okay, from all this tracing table I will again start the explanation in the next class. This both multiplication, and it is very much important. It is very much important, this both multiplication. So in the next class I will again start from this tracing table, because today it is not so much time left, so I will not able to complete this. So that's why, because it should be completed, and in next class I will do that, this multiplication and all